So he knew that those positive charges repelled positive charges, and negative repel negative. But what was interesting is when he fired in all of these beams, these alpha particles, some interesting things actually occurred. What he discovered was that inside those gold atoms that it was mostly space, and that they were not plum, like the plum pudding of positively filled material. He decided that the center was small and dense and positively charged, and that they repelled his positively charged bullets. He called the center a nucleus. This is basically what he said, was that inside the nucleus you have all these positive charges, outside you have these negative charges, and that they did attract to each other, but they also would scatter. If he shot negatives out here, they would repel. The next was the Bohr model, which is by Niels Bohr. He was a Danish scientist, and he actually looked at electrons. And what he said was that they stay in these very specific energy levels and that they travel in circles. This is a little bit different than what his model was. What he said was they move in definite orbits around the nucleus, looking a lot like the way the planets circle the sun. Okay, they do not jump, and they stay a specific distance from the nucleus. From there, and in recent years, roughly about 30 years, we do get this new model called the wave model. And this is what sets up this study called wave mechanics. And what it says is that the electrons do not move in a definite path like the planets do, but that it's impossible to determine the exact location of an electron. Yes, it's outside that nucleus, but it does not travel in nice, neat little circles. It kind of jumps around, and that you really cannot predict it. In that electron cloud, which is the outside of that nucleus, what we do know is that the electrons do not move in random patterns. There are very set ways that they go. They just whirl really, really fast, and so it's very hard to predict where they are. Depending on how much energy, they can actually get locked into a specific part. The ones with the lowest energy are found closest to the nucleus. The ones with the highest most energy are found outside and farther away from the nucleus. We will practice drawing some of these, so you'll see that a little bit better. And this is kind of summing it all up. We started off with the Greeks with Democritus, and he said that it was indivisible, but nothing else. 2000 later, John Dalton came up. He said it's also indivisible, and came up with his four-part theory. Then we start getting more advanced in our technology, and we get J.J. Thomson, who discovers the electron, and remember those were called corpuscles. Then we have Ernest Rutherford, and he really focused in on the nucleus, but also helped confirm J.J. Thomson's discovery of the electron. Then we have the Dane, Niels Bohr, who really focused in on orbits and the electrons. And then finally we have the wave model that dealt with the electron, with the nucleus, and the electron cloud to help us discover. And that's it for the atomic theory. You don't need to necessarily know all the scientists, but you do need to know the progression of how the atomic model came about.